Hi class. Um, this is the breathing tube model that I created in SolidWorks. If you remember from my presentation, this is the geometry. Let me just describe it a little bit in SolidWorks. So the geometry consists of a hollow tube. So if I was just going to open this tube, go ahead and open it as a separate model. It consists of all it is a chamber. Let me see. It's a hollow chamber with some separators in the middle to separate inlet from outlet. If I was going to go ahead and do a cross-sectional view. So if you look to see, there's an entrance here with just an inlet-outlet separator. Then it's pretty much empty all the way until the end. So the only thing of interest here is this little separator plate. Otherwise, without this plate, it's just a channel. It's actually a channel with one end that is closed, the back side here, and so it has two openings. So let's go ahead and go back to this is the assembly. If I was to hide that tube, so my assembly inside are these heat sinks. All right, so this is geometry that I created, and all it is a metallic heat sink with one side here at the top and one at the bottom. So this top row basically experiences the fresh coming air, and then I added these separators. Again, it's just like the entrance separator on the left. It's there just to separate top inlet and return flow. Otherwise, when I would run the fluid analysis, it would come in and it would automatically start mixing with the bottom. And what I want to do is I want to force the fluid to come in through the top entrance here and then circle around back here and come back that way, so that we have fresh fluid coming in, air, and these plates are going to be at the top are going to be hot. It's going to heat up the fluid, and then the plates at the bottom are going to be cold. So that's the geometry there. I have three. All I did is I created this heat sink, and I created these flow separators, and I basically did a linear pattern of these heat sinks, 1, 2, 3, three of them. I forgot how far I spaced them apart, and then that's pretty much it. So when I created the model, I had to create these things. So when I run flow simulation in SolidWorks, you can't have openings. You have to be able to tell the flow where do you want it to start and where do you want it to end. So you have to put these things called lids. So it's as simple as just plugging that hole up. So if I was going to show you the tube, you plug it up with a lid. You probably see right here, this is the computational flow domain is this diagram here. So the program basically just all it does, it's all this computation within this box here. And again, if I was to hide one of these, again, it's an empty. Here's where the air enters, and this is where. So I'm going to hide that. This is where it exits. Okay. So when you run it, you'll notice if you ever want to investigate flow simulation in SolidWorks. Again, it's free to all Long Beach State students. So it's a nice software package. You have to. So in order to get it to run, you have to put cover plates there, or what they call lids. And so I'll show you what that lid is. It's just a simple plate that just plugs the hole up. It's flush with the outside, and that's important because if you don't have it flush with the outside, if you just kind of have it just popping out to the left, then it won't work. And the way you actually run is to go to, if you have SolidWorks on your computer, again, it's late in the game now, but with our last class happening next week and this project due in 2 weeks. Anyway, so it's late in the game, but if you were going to try to attempt this, what you do is you go to Tools. They have the simulation here, but this simulation, these set of tools are basic. This tab here is for SolidWorks simulation, which is not flow simulation. It's heat transfer, it's stress analysis, but it's not a CFD. It's not their CFD package. To look at their CFD FlowWorks, you have to go to Tools, and at the very top you're going to see these three options here. You go to Flow Simulation, and then Project, and then you create a new project with the wizard. It's a nice tool. It takes you through basically about 5 or 6 steps to start a simulation. You can also use Flow Express, but Flow Express isn't that great because it only works if you have one part. And in this case, for this simulation, we needed to have these heat sinks and these separators. Though these separators could probably be designed right into the outer body, you would need, and then for FlowWorks, you wouldn't need to put these closeout lids. So again, for Express to work, and all SolidWorks software has the Flow Express, kind of a free flow simulation tool, but it's very limited. I don't think it lets you do heat transfer. I'm not sure, and it definitely doesn't allow you to bring in extra parts like this. So it's something you probably wouldn't be interested in. I never use it. I just go right to flow simulation. So I was going to go ahead and show this again. So again, to get to flow simulation, you go here, Tools, Flow Simulation, Project. You can do New if you're experienced with this, or you can go to Wizard. It takes you step by step. Okay, and then so I actually ran a flow simulation already. In lieu of time here, I'm going to show you. So it's an extra in the feature manager tree on the left hand side. When you run flow simulation, when you actually start getting it configured, this will pop up. And I call this project sterilizer because that's what we're doing. We're trying to see the effects see if we can sterilize air as it comes in and cool it back down before you breathe it. So when you run the project, it takes you through all these steps. You select materials, set what kind of fluid, and then you select boundary conditions. And maybe I can run this on the next video. I can maybe run this step by step through a brand new simulation. But this is just kind of a introduction, high level. So I actually set everything up, ran it, and you get a results. And then I loaded the results. So I'm going to show you what this looks like. All right. So you can see this basically just shows you, because this is internal, it would be hard to see because of the shell, but it shows you what the flow looks like. I had in my boundary conditions, I had a flow rate of I think it's 0.6 liters per minute. I think is kind of an average flow that a person would take in. Kind of like if you're doing, where everyone's talking about these ventilators. If you were doing a ventilator study, you would go with such a flow rate, something like, or anywhere between 0.6 and 1 liter per minute. So I believe I picked 0.6, which actually translates into, you have to use, I'm set up for English unit or SI units, so that translates to 1 times 10 to the negative 3 meters cubed per second of airflow rate. And then at the exit here, I just have it. In reality, the person will be breathing this, and there might be some, some pressure, some back pressure from the mouthpiece. But I just said, pretend this is just open to the atmosphere. In other words, you're just dumping all the air out. So you have to specify an exit and the boundary condition is an inlet condition, and then the outlet. So my outlet condition, I just said static pressure, which is atmospheric pressure. And they came up with this. So if I was going to hide this tube here to show you more, I wonder if I can do it here. I might have to come back up here. I'm going to hide my tube, and now you can see the flow where the pressure is highest in red and lowest in blue, but the lowest it gets is static pressure, so it's basically slightly above static pressure as it enters. And it has, so it's, but if you can imagine, if these things had arrows, it would be going this way, and would circle around, come through and then come back this way and exit. So this is what the flow trajectories are. And I think I only, in this flow trajectory tool, I said I specified 20 streamlines. So 20 points that the flow originates at the top. I can obviously increase that to a higher value, say 40. I think that's all I'm allowed to do here. I don't think I can change how these lines look like. I can't put arrows. I think that's another results tool. So if I hit return, it'll just increase how many streamlines I have. So basically it just helps you with the visualization. You can see kind of how the flow originates from this entrance here, and then it goes around these heat sinks. And the idea here is I want to be able to heat these up to heat up the flow. And even though this is showing back pressure, the color is showing the reds come up as the higher pressure, the blues come up as the lower pressure as this thing exits, and it drops pressure as it's going through the heat sinks. This should show you what the air temperature is going to look like when I start introducing heat up here and heat and cooling down here. So this should be a representation. So this is the free, I shouldn't say free, but it's part of the SolidWorks simulation that we're offered at Cal State Long Beach for all students. And again, this is just the general. Okay.